Okay, people, going to give a quick look here at 2019 question 6. Now, normally I would say to start with the ellipse, but I think this is the only time I would say that maybe that parabola down at the bottom, you could start with it or you could start with the ellipse. But in this case, for once, I will start with the parabola, I think. So I'm going to start down pretty low here on the sheet. So the base of this was 80. And another 80. And the height of that parabola was 40. Now I'm going to use, normally you'd have to do division of lines for this, but not in this case, because the numbers were user friendly. They made it quite straightforward for the person doing it. So I'm going to just divide this into 4 equal distances here and 4 equal distances there. So this is the vertex of the parabola. So I might just zoom in on this here now. So they go to the vertex and so here's my first point, second point, third point, and here I think I'll put this in pen just to make it more visible. Now, lots of choices for doing the other side, but again, just in relation to time, I'm going to just use the fact that it's symmetrical. So I'm going to just grab a compass. So that's our first distance. Second, third. So there's our parabola, and what we see from the drawing here is that there is an identical parabola down 20. So I'm going to just mark down 20 here. Now this is the center down 20 for a circle that I need. So I'll just draw that circle in light. So that is the circle. Now basically what I want to do here now is I want to just extend these lines down here so I can use all of them, and I want to put an identical curve 20 down. So I'm going to just start marking 20 so we know it's the bottom of the circle is point E. So I'm just going to mark 20, 20, 20. So that's my identical curve, but if I wanted to know exactly where it crosses the line here, just take a horizontal from the bottom of the circle over, and where it hits the curve here, come down, that's where it crosses the horizontal here. So I know now that that's the point D there, the flat one coming in, and this is point F, and the rest of this I'll draw. So if you didn't have that found, I'll just show you there, you just continue that with a dotted line. Just to show there that you were going definitely for that point. So that is the parabola sorted. Now, the next thing I'm going to do here now is I need a 60-degree angle from B, and I want to come up a distance of 30 vertically. So that's 30 vertically onto that. And that point there is J, which is the bottom of the ellipse. And the ellipse now goes at an angle of 60 degrees. So we've looked at the parabola, so I want to try and zoom in now on the ellipse there, just so people can see, because this question seemed to cause a lot of hardship for people doing it. Now the major axis is 85. So there's the center of my ellipse, and I'm going to draw that major circle at 85. Now I'm going to draw it a bit heavier than I would like to, so people can see all of that circle. Okay. Now, so that's our major circle, and perpendicular is going to be the minor axis, but we don't know the length of that yet. So the focal points are N and P. So the focal points are 70 up and down here. So that's one focal point. Here's the other. I'm going to call them F and F1. So we know now, or you should hopefully know, that half the major axis swung from the focal gives you the end of the minor. So that's the end of the minor axis there. So I can draw the minor circle. Now, what I'm going to do next is I would like to find my pencil sharpener. But I'm going to colour in the major axis in green. and I'm going to colour in the minor axis in red. Now the reason for that, and the reason this question I think caused so much problems, is because people are used to doing like horizontal and vertical for their construction of an ellipse. When the ellipse is drawn, just zoom in here for a second, normally our ellipse is turned like that, and the major axis is horizontal and the minor axis is vertical. So when we're finding our points there, we often think down and across, but really it's parallel to the major and parallel to the minor. So when I'm coming along to do this here now, you must remember there that down and across is basically parallel to the major and parallel to the minor. So I'm going to put on the spokes. So the spokes are, because the axis is at 60, I'm still using all the normal angles. So they're all my normal angles. So now I'm going to start here with this first spoke. So down is parallel to the red and across is parallel to the green. So that's our first point. So that's down and this is across in relation to, so parallel to the minor, parallel to the major, and I'm going to just draw in this much so that we can see what's happening. And then again, up is parallel to the minor and across is parallel to the green one, which is the major. That's the next point, and the next point, and I now have enough points for half the ellipse. And so the other side is the same. Down, across, parallel to the minor, parallel to the major, and parallel to the minor, parallel to major, parallel to minor, parallel to major. And that there now is all my points. So I'll just finish out this ellipse. Now don't make it too pointy at the ends. That's a common mistake there, of making it too pointy at the ends. So like bring it in early and flatten it along. So there's our ellipse. The next move there then is we need to divide 70 into, oh yeah, sorry, they're just 15 and 15 out, and that's up and down 15 as well. So I need to mark some points here. So we've got up 15, down 15. They join back to the focals. Now I'll draw them in a bit heavier so you can see them hopefully on the camera. So they're going to tell us the heights, and I need then to come just 15 to either side. So 15, 30, 15, 30. we'll put these on with pen. So they just stay contained within those sloping lines. And there was also a heavy line, I think, going all the ways to the focals. So that's my design in the middle of it. Now, the last part here then, just zoom down to here now. So this point B here. So we have one heavy line just going to J. So that's okay, I can just heavy that in. But the final point here, BT, is a tangent. Okay, so now that has a construction, because we've got to find where exactly it touches it. There is a construction for that. So the formula is, wherever you're drawing the tangent from, draw an arc through the near focal point. So here's my arc through the near focal point. I want to swing the length of the major axis from the far away focal point. So that's from the far away focal point, and where they cross is here. I'm going to call it point M, and I'm also going to put this in green, I think. I found the pencil sharpener, that's the good news. So I'm going to join point M back to the far away focal. And this here is the point of contact. POC for point of contact. And that joins to there. Now it's very important to do that construction and to leave the arcs there. So finally now, I just need to heavy in these arcs here. And that there is the full question, but the parabola is basically 4 equal heights, 4 equal widths, and that. So best of luck with that.